Hi there, welcome to Just Another Dev. And today in this video, we are going to discuss about the two other data structures in JavaScript which are provided inbuilt with the language, which are basically map and set. So map and set data structure are analogous to our objects and array data structure that we have seen in the previous video with a few differences. So let's see the similarities and differences of map and with respect to the object. Similar to an object, map is also used to store the key value pairs, and the key inside the map can be anything. It can be a string, it can be a number, it can be another object, while in case of objects the key could only be either a string or a symbol. So that is one major difference between map and object, that you can use key of any type, and obviously the value in both of the map and object can be of any type. You can store any value corresponding to the key. Also, map should be a preferred choice over object when there are too many insertions and deletions operations required, right? So if you have an object and you are doing a lot of insertion and deletions, then maybe it is a good idea to convert it to a map and then do those operations, because map are optimized for those kind of operations, and we'll see that when we cover the time complexity part. The next difference is the key in map are ordered as per their insertion order. So if you are adding a key A first and then B, then C later on, then the order of these keys will be maintained in the map, while the order of the keys in object is not guaranteed to be maintained. Let's see how we can create a map. So in order to create a map, we just need to initialize the map constructor, which we can do just like this: const map equals to new map over here, and this will create a new map object for us. And unlike objects, we should not be creating key value pairs on map like this, though it will work and it will not give us any error, but this is not the way we should create property on map, because it will basically take the generic object behavior and it will work, but it will not show up as a map property. So if you see here, it is showing map and it is showing 0 over here, which is basically the properties in map that we are storing the key value pair in the map. So it is showing us a 0, but still you can see 1:2 over here, right? So even though it is working, we should not be using it like this. If I do a map.size over here, you will see it is going to show us a 0 size. Sorry, this map.size is not a function. I'll just run this again. Okay, so we can see the size is 0 over here, right? So let's see how we can set properties on map. So instead of this, what we'll have to do, we'll have to call this set method, where we have to pass the first argument as key and the next argument as value. So let's say if I'm passing a name key, the value is John Doe, then I'm passing a number key, and then let's say the value is boolean. Also, if you remember, I mentioned that we can use any value as a key, so I will use this object as a key in the map. Okay, so even this object I can set as a value, and sorry, in this object I can set as a key. Let's say the value is 3 for this. So if I just run this, sorry, I didn't put any console over here. Let's see what all present in the map now. So if I do a node map.js, we will see there are 3 items, 3 key value pairs. First is the name, which is corresponding to this John Doe. So string key, string value, then we set this number key and boolean value, so it has a number key and a boolean value. Then the third one is basically an object key, so we can see it over here, and then it is corresponding to the value 3. Now let's see how we can check if the value is present or not. So in order to check if the value is present, what we can do, we can just use the has property of map. So I'll just do a console.log map.has, and let me just remove this console. And if I just say 3, then it would not give me any result because it does not have any key called 3. So it is telling me that false, right? So basically it does not have any key called 3, but if I use 1, then it will give me the value. Okay, so it has returned true, right? Now let's see if I use this thing, this object. I create a similar object over here. Let's say first name, again the value, dummy name, right? So this object is similar to this object only, but let's see if it provides us the answer as true or false. Okay, so even though the value are similar, right, the object looks similar, this is an entirely different object and this is an entirely different object. Both of them are referring to different memory locations. So that's why map returns us a value called false, right? So map is not able to identify this object and it is returning false. But if I use the object that we created above, it should give us the value as true. Okay, so now it is giving us the value as true, right? So this is basically how you can access the value, and let's see how you can get the value, right? So getting the value is also pretty much straightforward. You can just use get instead of has, and it will give you the value which is corresponding to the key that you are providing. Okay, so we did node map.js, and with this particular object key we have a value of 3. So this is how we can basically get the particular value for an object. And the last operation that we are going to see is the delete operation. So what we can do is we can just provide a delete operation over here, and it just takes the key, so it does not take anything else. And if I just do a map over here, okay, so now we are seeing that when we print the map after deleting the object key, it is no longer there, right? Now if I try to delete a key which is not even a part of this map, then it should not give me an error. It is just going to ignore it, and then we can see in the map we have all the values present, right? So this is basically how we can create a map. We can set some key value pairs on the map. We can check if the key is existing on a map using map.has, and we can get that particular key's value by using map.has. And finally we can delete a particular key value pair using map.delete, right? If the value is there, it will delete it, and if the key is not found, it will just ignore it. So let's talk about the time complexity now. So let's see the time complexity of map, the insertion operation. So for an insertion operation, the time complexity of a map comes to be O of 1. Same goes with the delete operation. The time complexity of delete operation is O of 1, and same for the random access as well. So if you just want to access the value of a key, you can directly access that using map.has. This we can do it via map.delete. This is map.set. This is map.has or map.get. If you want to get the value, you can use map.get. If you just want to check if the key is present, then you can use map.has. And if we talk about the search, let's say if you want to get all the keys and basically search among those, let's say for example if you want to get all the numeric keys, right? So then you will have to fetch all the keys and then find out which key are numeric or which key is an object. So that will amount to O of n. So this is about the time complexity of a map, and though it looks very similar to what we discussed in object, there is a difference in the way object is stored in JavaScript versus map. So map are optimized for frequent updates and frequent basically insertions and deletions. As ECMAScript specifies that the time complexity of map should be sublinear. By sublinear, it means it should be less than O of n. So internally, the JavaScript engines store map in maybe a hash table format or search tree format, and it depends upon different JavaScript engines how they are going to store it. But one thing remains common, that the time complexity of these will be sublinear, always sublinear, even though there are tens of thousands of keys present in the map, right? And therefore we should be using map in place of objects when there is a lot of insertion deletion operations that we are performing. On the other hand, objects are stored differently. For example, V8 engine uses some kind of a shape interface to store the shape of the object and the properties of object separately. You can read more about this in the V8 documentation. As we discussed in the last video, where I mentioned that V8 changes the object as a fast access object or slow access object depending upon the number of insertion and deletion. Because if we do a lot of insertion and deletion, the shape of the object will keep on changing, right? So that's why it is always a good idea to use map when there are a lot of insertion and deletion operations, or if you foresee any kind of insertion and deletion on your object, then go for the map. So that's mostly about the time complexity of map data structure. Let's move ahead with the set. Set in JavaScript are very similar to array, but it is used to store a collection of unique items. Here unique is the one of the key differences. So basically you cannot store duplicate items inside a set unlike an array, right? You can store any item in an array again and again. So it can be an array of 1 1 1 1 and there won't be any issue in that. But if you try to insert one again and again in a set, it will make no effect, right? So there will be only one which will be present in set, right? Also, just like arrays, you can store heterogeneous data types. So basically we can use object, number, string, whatever we want, we can store inside a set, but it has to be unique. That is the only constraint. Also, set provides better time complexity in case of access, right? So set has a method called set has, where you can basically check for any item to be present in the set, while array has array includes, which has a linear time complexity, basically O of n time complexity. We will talk about it in the time complexity part, but let's see how we can create a set in JavaScript. In order to create a set in JavaScript, we just need to initialize its constructor, where we are going to write new set and it will create a set for us. So in order to add elements into the set, we can just use set.add and we can use whatever data type we want. So if I'm going to use a number here, let's say in the next item I am using a name called John, and we can also insert an object just like an array, which can contain heterogeneous data type. Here also we can basically add any data type that we want. So let's add this thing as well, set.add, and I'll just use this object, and if I do a console log set, we should be able to see all this data present over here. So it contains 3 items. First is the number 1 that we added, then John, and then this object. Similar to the map part, we can also check if the value is present in an array. But before that, let's see if I add 1 again, what will happen. So as we said, right, as we discussed, that it will only allow unique values to be present. So you see, even if I add 1 here again, it doesn't make any impact, right? So it only checks that 1 is already present, so it will not add it again. So that is one of the difference between array and set, that you can only add unique values into the set. Okay, so now let's see how you can see if a value is present in the set. So if you do a set.has, which is similar to the method in map, and if I just do a 1, it will basically return true. But if I change this value to, let's say, 10, it is going to return false, because this is not present over here. Similarly, if you want to remove some value, you can use set.delete, and you just need to provide the key here. So even if you provide a wrong key, it will not throw any error. And let me just do a console.log set again, and I'll just do a console.log set before as well. So let's see. So initially it was 3. I mean, the size of set was 3. How also the size of set is 3 because it has nothing to be deleted over here. But if I use this set delete 1, then it will basically go ahead and remove this value 1 from the set. So you can see we have a 1 John and this object over here, but as soon as we removed it, it returned true and basically 1 is not here anymore. So this is basically the simplest operations on set that you will be mostly using, and it has a set.size as well, similar to what we have in map. So you can go ahead and look at what all different methods it have, what else you can use. But for our data structures use case, these are the basic operations. And now let's look at the time complexity of these operations. Similar to map, set are also implemented using some kind of hash table inside the JavaScript engines, and therefore the time complexity or insertion and deletion in a set comes out to be closer to O of 1. And only in case of large number of keys, when there could be a hash collision, it can be slightly higher than O of 1. And as this ECMAScript specification suggests that the time complexity for set has to be sublinear. That means it will always be less than O of n. So this is basically for majority of our use cases, we can assume that the time complexity for insertion and deletion would be closer to O of 1 only. Also, the time complexity for basically checking the element in a set is O of 1, so which is basically the set.has method, and in contrast the array.includes method has a time complexity of O of n because it will go through all the items in the array and then figure out if the element is present or not, while set.has has nearly constant time complexity. Again, only in case of hash collisions the time complexity may be slightly higher than O of 1, but as I said, in majority of the use cases it will be O of 1. So it is always a good idea to use set when you have a large number of items, large number of items to be stored in a collection, or if you want to have unique items, right? If you don't want to store duplicate items into your collection, then also set becomes a better choice. So this is mostly about the time complexity of set in JavaScript. I hope you liked the video. Thanks for watching and stay tuned.